In this video, we will be going over a quick review of geometry and measurement. So let's start off with some formulas. A formula for finding the area of a rectangle, which is going to be in units squared, is going to be area equals base times height. Now the base is just one side and the height is like the other side. How can you tell what the base and the height is? Well, you look for the right angle. And the base and height is either going to make a T or an L or an I, something like that. If you look at the parallelogram, the formula again is area equals base times height. And where's the right angle? Here it is. So if you have like a number that goes with this, like a 7 or something like this, number has nothing to do with anything. So that is not included. Your base and height, remember, makes like a T or an I. In this case, it makes like this upside down T because there's the right angle. Let's look at the trapezoid. This is probably the most complicated of all the formulas. Again, you know the height is the height because it forms a 90-degree angle with the base, and technically it forms a 90-degree angle with both bases. And yes, we do have two bases. That's why it's called B1 and B2. You may have like some information like a number like 12 over here, but that has nothing to do with anything. So make sure when you're finding the area of a trapezoid, you're not including these slant heights. So the formula is area of a trapezoid is B1 plus B2 times the height, and you're dividing it by 2. Or you can just say half of base 1 plus base 2 times height, and you get the same answer. Yeah, some people prefer A equals 1/2 or 0.5 B1 plus B2 times the height. And they both work. Let's go to the triangle next. Here we have a couple different triangles. The formula is of a triangle is area equals base times height divided by 2, or some people prefer area equals 1/2 or 0.5 base times height. They both mean the same thing. And we are looking for the base and the height. The base and the height, again, form a 90-degree angle, so it should form a perfect T or an I. Or an L. So again, height and base right there. It makes like a backwards L. So, for example, this slant height is nothing when it comes to the area. You don't need this slant height to find the area. And sometimes the height will be found outside. So like it forms a 90-degree angle with the base. And normally there's going to be a dotted line that goes out there also. But again, the two lines that touch that 90-degree angle are those. So the base is right here, the height is over here. This is not related to our area at all. So they say a triangle is decomposed from a rectangle that is cut in half diagonally. What that means is that the reason why area of a rectangle is base times height and a triangle is base times height divided by 2, or half of base times height, is because basically a triangle, if you take two triangles and put them together, you can make a rectangle or a parallelogram. Let's go to the next section. Find the area of the base. To find the volume, you find the area of the base. Multiply the area of the base times the height of the prism. So there are two formulas. The one they want you to use is area equals big base, which is it's going to be an area written in square units times height. So in this case, the base is right over here, and you're going to multiply that by the height, which is right over there. You're probably more familiar with this, which is area equals length times width times height. And remember, the length and the width would be like, this would be the length, and this would be the width. So if you multiply the length and the width, you get the base. And if you multiply by the height, you get the volume. So it's just two different ways of doing the same thing. And remember, volume is measured in cubic units, measured in cubic units. That would be like units cubed, or not UN, but U cubed, like centimeters cubed or inches cubed. And it is measuring the amount of space inside of an object. Finally, we're going to do the bottom. The total covering on the faces of a 3D object. What are some examples of that? That's like wrapping a present. Sorry, I did not write that very nice. Wrapping a present. And this is called the surface area. Wrapping, hopefully I did spelled wrapping correctly. A present, or we could also say a cardboard box unfolded. This is another example of a total covering. Unfolded. Or you can paint the sides of a 3D figure, and that's also an example of surface area. So to find the area of various faces, so if you want to find the surface area, you want to find the area of the various faces. So for example, this makes a triangular prism. It's got two bases, and you can see the dotted line indicating the height, and this down here would be the base. So you have two triangle bases. Actually, two triangle bases. That's a triangle right there. And then you have three rectangles. Over here you have a, for number two, or not number two, but the second one, you have a rectangular prism. So basically you have three sets of, you have six rectangles, but they're all in pairs, because like one would be like the front and the back, or the left and the right, or the top and the bottom. So you need to find the area of all three and basically double them. This next one is a pyramid, a rectangular pyramid, or a square pyramid. So you have square in the middle, and then you have four triangles. And then this last one is a triangular pyramid. So really you need the height of this as well. But you have one triangular base, and then you have three faces, three triangle faces. I should probably put a base right there, one rectangular square base. And then to find the surface area, you basically find all the areas of these shapes, these flat shapes, and you add them all together. And that is our review of geometry and measurement. Go ahead and try some questions on your own. Good luck.